Good morning, ladies and gentlemen. My name is Peeratat Krisanaprakornkit, and I'm a fourth-year medical student from the Faculty of Medicine, Siriraj Hospital, Mahidol University. The title of today's talk is The Inhibition of Breast Cancer Cell Migration and Invasion by the Neutralizing Antibody against a Disintegrin and Metalloproteinase 9, as known as ADAM9. So a set of newly developed monoclonal antibodies, the WKD clones, that are able to target ADAM9, which is overexpressed in breast cancer cells and plays a crucial role in their cell migration and cell invasion. Therefore, we aim to study the effects of these monoclonal antibodies on the inhibition of breast cancer cell migration and invasion. Breast cancer is the leading cause of cancer-related deaths among women worldwide. Despite significant advancements in immunotherapy for breast cancer, challenges still remain in identifying the biomarkers to better select patients and improve treatment outcomes. ADAM9 is a transmembrane protein that functions by shedding cell surface proteins and plays a crucial role in carcinogenesis, particularly in cancer cell metastasis. So why study ADAM9 in breast cancer? Because it was first identified in breast cancer, and its overexpression is positively correlated with tumor progression and poorer prognosis for breast cancer patients. A set of newly developed monoclonal antibodies, the WKD clones, have shown their ability to detect ADAM9 in oral cancer models at the cysteine-rich domain, with consisting of 11 amino acids as determined through an approach of phage display and ELISA of overlapping peptides. So the objectives of the study were to assess ADAM9 expression in breast cancer cell lines using the WKD clones by 3 methods: immunoblotting, immunostaining, and flow cytometry, and to characterize the neutralizing effects of the WKD clone on their cell migration and invasion of the breast cancer cell lines in vitro, using the ALAMA Blue, the wound healing assay, and the invasion assay. Immunoblotting of the WKD clones WKD clones were able to detect the expression of ADAM9, active ADAM9 in the cell lysates of both SKBR3 and MCF7 breast cancer cell lines, as well as in oral cancer cell lines as cell control, with the commercial anti-ADAM9 antibody obtained from Abcam showing detection at the same predicted size. The immunofluorescence assay of the WKD clones, the clone 4, 5, and 9, were able to detect to localize the expression of ADAM9 in both breast cancer cell lines by immunofluorescence compared to the negative immunostaining by the isotype control antibody. Note that the clone WKD9 was particularly effective in detecting the expression of ADAM9 in both breast cancer cell lines. However, none of the WKD clones were able to detect the expression of ADAM9 in either cell line using flow cytometry, whereas clone M61E9 that targets CD147, a tumor cell marker, showed positive detection by flow cytometry, as can be seen here. The cytotoxicity test by ALAMA Blue revealed that none of the WKD clones show significant toxicity against breast cancer cell lines compared to the treatment with the PB1 isotype control antibody, even after 72 hours. Note that we use 10% DMSO as the control for cell toxicity. The results from the migration experiment reveal that among the 3 clones, the clone 4, 5, and 9, only the WKD9 clone shows significant inhibition of migration of the MCF7 cells, but not the SKBR3 cells. So as an example of the experiment, the pictures are shown below, showing that the MCF7 cells that were treated with 10 micrograms per milliliter of WKD9 show positive inhibition of migration as compared to the same dosage of the treatment with the same dosage of the isotype control antibody. We initially included the video, but due to technical difficulties, it didn't play out. And the treatment with the mitomycin C served as the control for the cell migration inhibition here. And treatment with the 10% fetal bovine serum served to accelerate the cell migration. Only the MCF7 cells that were treated with 10 micrograms per milliliter of the WKD9 clone revealed significant inhibition of cell invasion, similar to the results from the cell migration. However, the results were not significantly inhibited in the SKBR3 cell line. So the conclusions included that all of the WKD clones successfully detected ADAM9 expression in both cell lines through immunoblotting and immunostaining, but not through flow cytometry. And the treatment with the WKD clones showed no cytotoxicity in either cell line for up to 72 hours. And only the WKD clone showed the most inhibitory effect on their cell migration and invasion of the MCF7 cell line. So in conclusion, the novel WK89 clone has demonstrated effective suppression of breast cancer cell migration and invasion in vitro, suggesting its potential role to be developed as adjunctive treatment in breast cancer immunotherapy. And lastly, I'd like to acknowledge all of the parties involved. Thank you for your attention.
Thank you so much for your cohesive presentations. Do you have any comments or any questions? Okay, thank you.
Very much for the nice presentation. I have a question about why you select these two cell lines, these two breast cancer cell lines, and what different between these two, because we see the different effect on these two cell lines.
So we initially selected the two cell lines because we wanted to test on a limited number of cell lines before moving on to larger amount. Secondly, the difference between the MCF7 cell lines and the SKBR3 cell line is that they represent quite the opposite spectrum of breast cancer cells. For instance, the MCF7 cells, they have a histological subtype of luminal A, which means that they have estrogen receptor positive and they are progesterone receptor positive, and they have a much less invasive property compared to the other. The SKBR3 has a more basal-like histological subtype while having HER2 overexpression. Therefore, they represent a very different type of breast cancer. So we can in an overview of all breast cancers, see the effects of the clones on their on the inhibition of their cell migration and invasion.
Okay, so could you summarize the result that you found, linked with the cell type of these two cell types?
So we believe that the differences between the two cell types are down to cancer cell heterogeneity, which as I have demonstrated, because the WKD clones were only able to inhibit the cell migration and invasion of the MCF7 cells. So we believe that the SKBR3 cell line, which do demonstrate which are more an invasive subtype, they may use other mechanisms in order to do their cell migration and invasion. So we believe that we suspect that by inhibiting ADAM9, they might not achieve an optimal result. But these speculations should be investigated further in a future study involving more breast cancer cell lines.
So how could you confirm the specificity of the antibody to only targeting the ADAM9, not to the other protein?
So the WK89 is only the WK89 antibody, not the clone number 4 and 5. Only the clone number 9 show the detection of ADAM9 at the cis-rich domain of ADAM9 by an approach of phage display of random 12-mer peptides, followed by a ELISA of the biotin conjugated overlapping peptides that narrowed the amino acid sequence to the following 11 amino acids.